All right, in this video we're going to look at the beginning, initially, how to solve multi-step equations. This is 8th grade math. We are going to be doing this for the rest of the year, all right? And we're going to be using this method to be solving other more intricate, more detailed questions, so such as like a geometry, all right? We are going to be using the logic and the concepts that are involved in how to solve multi-step equations for the rest of the year. So this is something that you definitely need to focus on, that you definitely need to pay attention on, and we're going to spend quite some time getting to know this, all right? There's several things that are involved here. There's really going to be 3 steps that we're going to be using. Now, those 3 steps involve several different things, so just take that with a grain of salt, if you would. I mean, this is what I mean. The first thing that you're going to be doing is, if you were to read it in a textbook, or if you were to read it online or something like that, it's going to say distribute, then combine like terms, and then solve. I say step 1 is get rid of the parentheses. Parentheses. That's step 1. You want to get rid of the parentheses. You do that by using the distributive property, okay? Step 2, boxes. I think you all know what that means by now. There's one thing that you need to remember when it comes to the boxes. When you change the side, you change the sign. All right? And then step 3 is solve. Okay, we're just going to start working some of these problems. We're going to use those 3 steps. The step 1 is distribute or get rid of the parentheses. Step 2, combine like terms. That's another way. I mean, when we use the boxes, that's a way of combining like terms. And then solve, that means get the variable by itself. We're just going to start by looking at some questions here. All right, let's call this example A. And this is what y'all are used to seeing, or this is what y'all have seen in the past. Maybe not quite like this, but 6 equals 1 minus 2x plus 5. This is similar to what y'all have been doing before, in such that there's one variable here, or meaning that there's one variable on one side of the equation. What we are going to be looking at and what we're going to be getting into is when we have variables on both sides of the equal sign, when you have more than one variable or more than one of the same variable, all right? So step 1 is we're going to get rid of the parentheses. Well, we don't have to get rid of the parentheses here because there are none. We skipped step 1 here. There are no parentheses. So step 2 is you are going to do your equal sign first and then do your boxes. That is very important, okay? Now, when we do our boxes, this is a way of putting the variables with the variables, the integers with the integers. Or the numbers with the numbers without the variables, and then the numbers with the variables. We're going to put those on the same side of the equal sign. And I can't tell you how important it is to put your equal sign down there first. You want to keep your equal signs all lined up in a row. If you don't do that, you're not going to know if you're changing the side or not. So it does not make one bit of difference which side you put the variables on, which side you put the numbers on. What does matter is that if you change the side, you change the sign. You're going to hear me saying that till death this year. In this case, I'm just going to put the variables on the left-hand side, and I'm going to put the integers on the right. I have kids that do that every single time, and if you want to do it like that, that's fine. You're going to get the same thing one way or the other, because at the end, you're going to end up dividing, and you're either going to be dividing by a positive or negative, and you're going to get the same answer. Maybe I'll show you that in an example or two from now. Like, it doesn't matter which side you put the variables on. So in this case, I'm going to put the variables, and I say integers. It is possible for this 5 right here, if it was a 5.3, it is possible to have that, and that wouldn't be an integer. I just, for the lack of a better term, I just say the variables with the variables, the integers with the integers, okay? This 2x is our variable, but that is not a 2x. You got to use the sign in front of your 2, and it's negative. So since it is a negative side, and you have negative 2x, and it's on the right-hand side, when we put it over on the left, when we change the side, we're going to change the sign. It becomes 2x. It was negative 2x over here. When we change the side, it becomes 2x. All right? Cool. Now, my integers, I have a 1 that's on the right-hand side. Go ahead and just put that right in there. Oh. we're not changing the side of the 1, so we're not going to change the sign. It stays right there. I have a 5 that's on the right-hand side. I'm not changing the side of the 5. It's staying on the right. It's going to stay a 5. However, on the other side, we have a 6. When we change the side, we're going to change the sign. It's going to be minus 6 over on this side. Oh, this is a good question. Now, put your equal sign first. And now you're going to combine these terms together. 2x, you're not combining with anything else. It's going to stay 2x. On the right-hand side, you have 1 plus 5, which is 6. 6 minus 6, which is 0. So here you have 2x is equal to 0. You're saying which number multiplied by 2 would give me 0. And you could, do the inverse of multiplying by 2. You divide by both sides by 2. And I kind of gloss past that because at this stage right here, this step right here, I say which number multiplied by 2 gives me 0. That's just the way I think about it. But yes, you are dividing this side by 2. You're going to divide this side by 2. And 0 divided by any number is going to be 0. So that means that if I were to put a 0 in here for my x, if I were to erase this 2, or this x, and if I were to put a 0, change colors here. If I put a 0 right there, I'd get 1 minus 2 times 0 plus 5. Well, you would do, I'm going to write it over here. Negative 2 times 0, you do the multiplication first if you were to do your order of operations, which is your PEMDAS, right? 1 minus 0, because negative 2 times 0 is 0. So you'd say 1 minus 0, or you could say plus 0, doesn't matter. Plus 1 minus 0 plus 5. 1 minus 0 plus 5 would give you 6. So that would say 6 equals 6. That means the left-hand side equals the right-hand side. So that means our assumption that 0 is the answer is correct. All right. The only number that you could put in for that variable x to begin with is a 0 for the left-hand side to equal the right-hand side. That's the only time it would work. If you put any other number in there for x, it wouldn't work. The left-hand side would not equal the right-hand side. So let's look at examples more like what you're going to be looking at. Now we're going to have variables on both sides of the equal sign. So let's take this one for example. P minus 1 is equal to 5p plus 3p minus 8. Here we have variables on both sides of the equal sign. We don't have any parentheses, so we're going to move right past step 1 and we're going to go into step 2, which is the boxes. This side, this time, and y'all are going to see the more examples that you do, as the more that you get through these, you're going to know which side to put the variables on, which side to make the integers on to make your life easy. Sometimes it doesn't make one bit of difference because your answer is going to be negative one way or the other. But you're going to see the more of these you do, you're going to think ahead a little bit. You're going to play the tape forward a little bit. It's like, all right, I'm going to put the variables on the side that would give me the greater number, because that way I would be taking a smaller number from a bigger number and give me a positive answer. So just in this case, I'm going to put the variables on the right. I'm going to put my integers on the left, yeah? Now, in order to do this, let's just start with our variables. Over here, we have a 5p, not changing the side. We're going to leave it 5p. Same thing with this plus 3p, not changing sides. Leave it as a plus 3p. And then this p that's on the left-hand side, when we change the side, we're going to change the sign. It's going to be minus p. You see how I got that? Change the side, change the sign. 99 times out of 100, if you get the wrong answer, it's because when you change the side, you forgot to change the sign. So on the left-hand side, we have a negative 1 and we have a negative 8. All right, on the left-hand side, we have a negative 1. On the right-hand side, we have a negative 8. Well, we got to put those in the same room with each other. And how we're going to do this is this negative 1 is going to go right down in here in our box. Negative 1 is going to stay in my integer room. Negative 8, when I change the side, I'm going to change the sign. It's going to be plus 8. You can rearrange that any which way you want to. Like if you wanted to, you could put the negative 8 over on the left-hand side and make it positive 8 first, and you'd get 8, and then you bring the negative 1 down in there, it'd be 8 minus 1, which is a lot easier for us to think about than it is negative 1 plus 8. However, you get the same thing. Having said that, it doesn't matter the order in which you put it in the rooms. What does matter is that when you change the side, change the sign. So negative 1 plus 8 is going to give you 7. And then 5p plus 3p is going to give you 8p. 8p minus p is going to give you 7p. All right? So it says 7 equals 7 times P. This says which number times 7 equals 7. The only number that multiplies by 7 to give you 7 is 1. So you're going to divide this side by 7. You're going to divide this side by 7. That's the math that goes behind it. 7 divided by 7 is 1. So the only answer, the only number that I could put in for P to make the left-hand side equal to the right-hand side would be 1. All right, if I were to put any other number in there for the variables, the left-hand side is not going to equal the right-hand side. We're going to do one more example here. Let's use some parentheses. Okay, we'll take this one for example. Two times 4x minus 3 minus 8 is equal to 4 plus 2x. Okay. We're going to get rid of the parentheses first. You do that by using what's called the distributive property. The parentheses right here, we have, the reason why we have parentheses is because we are multiplying 2 times everything that's inside the parentheses. It's just a different way of laying the question out. To do step 1 here, to get rid of those parentheses, we're going to multiply the number that's touching the parentheses by everything that's inside the parentheses. That is all we're going to do here. We're not going to try to combine anything else together. So you're going to do 2 times 4x, that gives you 8x, and then 2 times negative 3, which gives you negative 6. We're not going to try to do anything else at this point. We're going to bring everything else down. All we did is we multiplied the number that's on the outside of the parentheses by everything that's on the inside. You're not multiplying this negative 8 on the left-hand side by everything that's inside the parentheses. We're subtracting 8 from all that. So now that the parentheses are gone, we're going to do our boxes here. All right? I'm just going to put the variables on the left. I'm going to put the integers on the right. It doesn't matter. What does matter is that when you change the side, you're going to change the sign. That's an I. Yeah, deal with it. Okay, 8x going on our variable stays 8x. Change side, change sign. This 2x, it is on the right. It's going to be coming over here on the left. We're going to make it negative 2x. On the right-hand side, we have a 4 plus 6. Change the side, change the sign. We're going to put all 3 of my integers in the integer row. 8 minus 2, that gives us 6x. And then 4 plus 6 would give me 10. 10 plus 8, give me 18. You divide both sides by 6, and the number that multiplies by 6 to give you 18 would be 3. So the only number you could put in the left to make the left, or in for x to make the left-hand side equal to the right-hand side would be 3. Now, just for the sake of argument, I want to show y'all something here. I'm about to have kids come around. Let's say I messed up. Let's say I did 8x plus 2x. And then over here I said 4 plus 6 plus 8. What I did wrong here is when I changed the side, I did not change the sign. And you are going to make that mistake. I guarantee you're going to make that mistake somewhere along the way. And this is what's going to happen. 8x plus 2x is going to give you 10x. 4 plus 6 is 10. 10 plus 8 gives me 18. And now I say, which number multiplied by 10 would give me 18? And it's like, kids like to say nothing. Well, there is a number that multiplies by 10 to give you 18. It's just a fraction, or it would be a crazy decimal. Is it possible for your answer to be a crazy bobo decimal like this? Sure. It is not possible for the questions that I'm going to be giving you. I know what the answers are already. I'm not going to give you anything where x is 18 over 10. Or 9 over 5, 9/5. I'm not going to give you anything like that. If you did that, you did something wrong. And 99 times out of 100 is when you change the side, you do not change the sign. So you don't raise your little hand and say, Mr. Pullman is wrong. You're going to take that pencil, you're going to erase it, and you're going to start all over again. And most times when kids do that, they figure out what their mistake was. All right? We'll look at the next more of these in the next video. Keep doing the next right thing. I believe in you.